Have you ever wondered just how vast and mysterious our universe truly is? From the planets of our solar system to the farthest reaches of space, there's one celestial phenomenon that continues to baffle and fascinate scientists and space enthusiasts alike: black holes. But not just any black holes, monster black holes. These cosmic giants make our solar system look like a mere speck of dust. Join us today on Amazing World Facts as we delve into the awe-inspiring world of these colossal black holes that dwarf anything we could ever imagine. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They are formed when massive stars collapse under their own gravity at the end of their life cycles. But while most black holes are born from the death of stars, some grow to unimaginable sizes, millions or even billions of times more massive than our Sun. These are known as supermassive black holes, and they reside at the centers of most large galaxies, including our very own Milky Way. To give you an idea of their scale, let's compare. Our Sun, which is about 1.4 million kilometers in diameter, is a gigantic ball of nuclear fusion at the heart of our solar system. It holds 99.86% of the total mass of our solar system. And yet, when compared to a supermassive black hole like Sagittarius A, the one lurking at the center of the Milky Way, our Sun is like a grain of sand next to a towering skyscraper. Sagittarius A has a mass equivalent to about 4 million suns, but it's not even the largest black hole we've discovered. In fact, it's relatively small compared to the true behemoths of the universe. Some supermassive black holes have been found to have masses exceeding 10 billion suns. These are the monster black holes, the cosmic giants that truly make our solar system look tiny in comparison. The birth of a black hole begins with the death of a star. When a massive star, at least 20 times more massive than our Sun, runs out of nuclear fuel, it can no longer support itself against the crushing force of gravity. The core collapses in on itself, and if the remaining mass is sufficient, a black hole is born. But how do some black holes grow into the colossal supermassive ones that we see at the centers of galaxies? The growth of a supermassive black hole is a process that takes billions of years. It begins by accreting matter, gas, dust, and even stars, drawn in by its immense gravitational pull. As the black hole consumes more and more material, it gains mass and grows larger. This process is often accompanied by the formation of an accretion disk, a swirling mass of superheated gas that spirals into the black hole, emitting powerful radiation as it does. But accretion alone cannot explain the size of the most massive black holes. Another key factor is the collision and merger of galaxies. When two galaxies collide, their central black holes are drawn together, eventually merging to form an even larger black hole. This process can create black holes with masses in the billions of solar masses, truly monstrous in scale. So what are some of the largest black holes known to science? Let's take a closer look at these cosmic titans. First up is TON 618, a quasar located about 10.4 billion light-years away. TON 618 is home to one of the most massive black holes ever discovered, with an estimated mass of 66 billion suns. To put that into perspective, if our solar system were placed next to TON 618, it would be swallowed whole in an instant. This black hole's event horizon, the point of no return, is so large that it could encompass the entire orbit of Neptune, the farthest planet from our Sun. Next, we have the Phoenix A black hole, located in the Phoenix cluster about 5.7 billion light-years away. This black hole has a mass of around 100 billion suns, making it one of the largest known black holes in the universe. Its size is so immense that it could easily engulf our entire solar system many times over. The Phoenix A black hole is surrounded by a vast reservoir of hot gas, which fuels its growth and emits powerful X-rays as it spirals into the black hole. Another giant is S5014+81, a quasar with a central black hole that weighs in at around 40 billion solar masses. This black hole is so massive that its gravitational influence extends far beyond the immediate vicinity, affecting the orbits of stars and gas clouds thousands of light-years away. S5014+81 is located about 12.1 billion light-years from Earth, meaning that we are seeing it as it was when the universe was still in its infancy. And then there's the black hole at the center of IC 1101, one of the largest known galaxies in the universe. This black hole has an estimated mass of 40 to 100 billion suns and resides in a galaxy that spans over 6 million light-years across. IC 1101 is a supergiant elliptical galaxy located over 1 billion light-years away, and its central black hole is one of the most massive objects in the observable universe. Monster black holes are not just passive cosmic vacuum cleaners. Their immense gravitational pull and the energy they emit have profound effects on their host galaxies. These black holes can influence the formation of stars, regulate the growth of their galaxies, and even eject vast amounts of matter into space. One of the most dramatic effects of supermassive black holes is the emission of powerful jets of radiation, known as relativistic jets. These jets are launched from the regions near the black hole's event horizon, where magnetic fields accelerate particles to near-light speeds. These jets can extend for thousands, even millions, of light-years, and their energy can prevent gas in the galaxy from cooling and forming new stars. In this way, the black hole regulates the growth of its host galaxy, playing a crucial role in its evolution. Another incredible phenomenon is the ejection of stars and other matter from the galaxy by the black hole's gravitational forces. When two black holes merge, the resulting gravitational waves can propel stars at incredible speeds, sometimes ejecting them from the galaxy altogether. These stars, known as hypervelocity stars, are some of the fastest-moving objects in the universe. Even in our own Milky Way, Sagittarius A star exerts a powerful influence on its surroundings. The stars closest to the black hole, known as the S stars, are whipped around at incredible speeds, completing their orbits in just a few years. The study of these stars has provided some of the most direct evidence of the existence of black holes, and has given us a glimpse into the extreme conditions near a supermassive black hole. As we look to the future, what lies ahead for these monster black holes? Over billions of years, as galaxies continue to collide and merge, the black holes at their centers will grow ever larger. Some scientists predict that the largest black holes could eventually reach masses of trillions of solar masses, becoming the dominant structures in the universe. But even black holes are not immortal. According to Stephen Hawking's theory of black hole evaporation, black holes slowly lose mass by emitting a form of radiation known as Hawking radiation. This process is incredibly slow for large black holes, taking far longer than the current age of the universe for them to lose a significant amount of mass. However, in the distant future, trillions upon trillions of years from now, black holes could eventually evaporate entirely, leaving behind a cold, dark universe. In this far future scenario, black holes would be among the last remaining structures in the universe. As stars burn out and galaxies drift apart, black holes would continue to dominate the cosmos until they too eventually disappear. But until that distant time, these monster black holes will remain as some of the most fascinating and mysterious objects in the universe, reminding us of the incredible power and scale of the cosmos. But what if one of these monster black holes were to wander into our cosmic neighborhood? What would happen to our solar system? As the black hole approached, its immense gravitational pull would begin to distort the orbits of the planets. The outer planets would be affected first, their orbits stretching and twisting as they were drawn toward the black hole. As it came closer, the inner planets, including Earth, would experience the same fate. The tidal forces exerted by the black hole would be so strong that they could rip apart entire planets, turning them into streams of gas and dust that would spiral into the black hole. The sun, too, would not be spared. As it approached the event horizon, the black hole would begin to tear the sun apart, pulling it into an ever-tightening spiral until it was completely consumed. The solar system as we know it would be utterly destroyed, reduced to a swirling disk of gas and debris. Fortunately, the chances of such an event happening are incredibly slim. The vast distances between stars and galaxies mean that even in a universe filled with billions of black holes, the likelihood of one passing close enough to our solar system to cause such destruction is minuscule. But the sheer power and scale of these monster black holes serve as a stark reminder of the forces at work in the universe, forces that far exceed anything we can comprehend. Monster black holes are the cosmic giants of our universe, dwarfing our solar system and even entire galaxies. Their immense power and mysterious nature continue to captivate our imaginations and challenge our understanding of the cosmos. As we continue to explore the universe, who knows what other incredible discoveries await us. Thank you for joining us on this journey into the heart of the universe's most enigmatic objects. If you enjoyed this video, be sure to like, share, and subscribe to Amazing World Facts for more fascinating insights into the wonders of our world and beyond.